to welcome everyone today. My name is Brian Coward. I'm the EDM Product Line Manager at Makino. Today we're in the Makino Experience Center, and we're going to be discussing wire EDM programming techniques today. So first I'd like to give you a little overview of what we're going to be talking about. So we're going to talk about some slug removal strategies. These are ways that you can optimize your programming. We're going to talk about no-core programming, which is pocketing, and then four-axis programming. Once we talk about these in the presentation, we're going to go to Alan Weeks from Opti Solutions, and he's going to give us a demonstration of the OptiCam software. So let's get started. So first, slug removal strategies. Standard slug removal strategy, we're going to discuss that, explain what that means. Then we're going to go through early slug removal and a slug removal after all of the rough cuts. So what do those mean? So a standard slug removal strategy. In OptiCam, how am I going to make this work? Well, the first thing I'm going to do, I'm going to come in here and I'm going to select my workpiece, and it'll bring up this window, and I'm going to not check do all first cuts before finishing. This is a strategy page of the workpiece itself. Next, I'm going to go to the profile. So this profile here is for the holes that are inside of this particular part that we're looking at. And when I hit the profile, I go to the setup page and the tagging page, and you can see here, tag removal method. I have many options of what I can do. For this particular demonstration, or this strategy, we're going to use stop, then wire cut tags on the first cut. Since this is a part where I have features internal and external, I need to set up a strategy for the outside of the insert. So I'm going to click on that particular profile, go to the setup page, tagging page, and I'm going to wire cut the tags at the end of the operation. So I got a little video here to show you, by setting up our program that way, how it's going to function. So now that we've programmed it that way, it's going to show us or simulate what it's going to do. So we're going to rough the holes, it's going to come to the stop, then we will drop the slug. So every hole internal, these are core pin holes and ejector pin holes, it's going to follow the same pattern. We're going to rough it, drop the slug, and then finish cut it. So that means every time I'm dropping a slug, the operator needs to be there to remove the slug. So this will go through all the holes internally, because that's what we told it to do. Now once it's done with the holes, it will go to the insert itself on the outside, and it's going to go all the way around roughing it, because we told it to wire cut the tag at the end of the operation, and then it's going to go around and skim cut it with the tag still connected. And then it'll come to the stop there, and then we cut it off, remove our part, and the part is finished. So that's what I would call a standard strategy for slug removal. So next we're going to talk about the early slug removal strategy. So again, we're going to go to our workpiece, go to the strategy page. Now, unlike the first time, where do all first cuts before finishing was unchecked, we're going to check that. We go to our workpiece profile. These are for the holes. Same thing. This is the same thing we did before. Stop and wire cut tags on first cut. The insert itself, we go to that profile, go to the setup page, tagging page, again, same thing. Wire cut tags at end of operation. So the only thing that we've changed is on our workpiece, telling it to do all first cuts. So just by checking one box, now this video is going to show how that will function. Come in here, simulation starts up, and now we did the same thing that we did before, right? It went to the stop and we removed the slug. But now instead of finish cutting, we're going to rough all of the holes first. So we're going to go around, rough all these holes and drop all of the slugs. Now you might say, well, why would I do that? Well, because the idea is to minimize the operator intervention time at the machine. So by doing this, the only time I need to be at the machine is when I'm dropping those slugs for those holes. So once I've dropped all the slugs, now it's roughing the outside of the part. All of this is unmanned machine time. Rough the outside, now it goes back to the holes. It's going to finish it. All of this is going to be automatic without the operator being there. And then it's going to go and finish the outside of the block. And then we're going to drop the part off. It's going to be the stop, operator comes back, and we cut the slug, and the part's finished. So what we've done simply by checking one box was maximize our unmanned machine time, which is how you make money with Wire EDM. So the last slug removal technique I want to talk about is slug removal after roughing. So same thing we did on the last one. We're going to go to our workpiece, and it's going to say do all first cuts before finishing. Next we go to our profile. These are our holes. Set up tagging. Now this time, instead of clicking on stop wire cut tags on first cut, we're going to go down here to the bottom and say wire cut tags at end of all first cuts. Profile for the outside of the part is going to be the same. We're going to have to go to setup and then wire cut tags at end of operation. So again, we just changed one more thing, and now this is how this video will show you the simulation of that. So on the last one, you remember we went and we dropped all the slugs and then it roughed and skimmed everything. Right here, now what it's doing is it's roughing everything without dropping the slug. So that means that the slug is still intact on the inside where the holes are. So it roughed all the holes, now it's roughing the outside of the block. Now you might say, why would I want to do that versus the way I did it before? Well, let's say I'm setting up the part right before I'm getting ready to go home for the night, and I want to get as much machining done while I'm not there as possible. By doing it this way, I get all the roughing done. Come back in the morning, I drop all the slugs. So I don't have to stay there to drop the slugs, right? I can leave immediately. So now when I come back in the morning, I hit start, drops all the slugs. And now once I drop all the slugs, again, I'm done. I can walk away, I can go do something else. It's going to skim cut all of the holes and skim cut the outside of the block as well. And then once it's done with the skim cut, again, we're going to cut that tag. There it is, part's done. So, very easy to change our process, right? There's one nice thing about this software. We can click one button, hit post again, and totally change the way that we're going to process this job. So that's just a few of the options that we have. There's many other ways that you can do it, many other tag removal concepts, but those are kind of the three major ones that I wanted to touch on today. So next, I'm going to talk about no-core machining. So no-core machining, what does that mean? Well, essentially it's pocket machining using the Wire EDM. If you're familiar with doing a pocket machining on a mill, same concept, but we're using the Wire EDM instead of an end mill. And what does this do for us? Well, it eliminates the need for slug management. So why would I want to do that? So if you think back to what I just showed you, we're dropping those slugs. We have to think about how we're going to process a job, when we want to drop the slugs, when we want the operator to be there. That eliminates that. This is primarily used for small features because Wire EDM is a slow process. You don't want to have a really big opening and no core it because it's going to take forever. But for small features, it's very, very effective, because if I have a small feature and I'm going to cut it like we did the first examples, I'm going to get a little sliver. And it's not going to be a big slug, and that can cause all kinds of problems in the machine. So using a no-core technique is very good in those particular instances. To keep in mind when you do no-core, the roughing NC code is created without an offset. Okay, so what does that mean? Well, I'm going to show you. So to do a no-core, we're going to go to the workpiece, and once we open the workpiece, there is a tab that says no core and start hole. So we go to start hole, and we can tell it what kind of start hole we have. Is it a round hole? Is it a irregular shaped hole? You could even make that, you create another figure inside of whatever shape you're cutting, and it could be an irregular shape. 9 times out of 10, it's going to be a round start hole. And then you would put in your diameter of how big it is. And then you simply check the box, no core, pocket first, and then you want to give it a step over distance. So that means how much of a step over am I going to have when I'm doing the no core. For Makinos and the technology we have, 8 thou, if I'm using 10 thou wire, seems to work the best, so that's why I use the 8 thou. And then I also have options on the pocketing mode itself. So I can either do a concentric, where it's just stepping over that 8 thou amount and cutting a circle, right? Step over, cut a circle, step over and cut a circle. For this particular job, I use spiral. So once I do that, then I go to my cut control page. I go to setup page, cut control. And right here in the roughing offset, this is where we load our cutting offsets and cutting power settings, which you'll get a demo of that from Alan a little bit later. But for no core, you'll get this message if you hover your mouse over that first offset. It's going to say no core is set. Value entered in this edit should be the wire radius, spark gap, and finishing allowance per side. The reason for that is that it's not going to apply an offset. So when you do your no core, the geometry is created for the rough cut, and the wire is going to move on the center of that geometry. And this slide kind of shows you that. So once I've done the program, it'll generate this code right here. You can see the green shape, and that wire will run right on the center line of that shape, and that's why you have to compensate for that. So the last technique I want to talk about right now is 4-axis programming. We get a lot of questions about 4-axis programming, how it works, how you should do it. Well, it's a type of taper machining. You know, you can just apply a taper if you want a T value, and it'll cut that angle. But this is a way to do it with 4-axis. And this is really common way to do tapering, because so many people use solid models today. You can just extract these angles from the solid model. So when you do 4-axis, you have to create both an upper and lower profile. So everything we've done previously is just a 2D profile. In this instance, we're going to create both an upper and lower shape. With the Wire EDM, you need to think about a Wire EDM, what it is. So it is a true 4-axis machine. And what does that mean? That means that I have an XY on the bottom and I have a UV on the top. And they're totally independent of one another. So the way to look at it is I've got two 2-axis machines built on top of one another. Because of that, I can program completely different shapes on the bottom and the top. So this is a very simple shape here, little circle square. So I'd come into program, I hit ruled surface instead of standard profile. And then when I click on the workpiece, I have to create an upper and a lower figure. So obviously I'd create my geometry prior to this, and then I select it. So if you look here on the graphics, the blue is my bottom geometry or lower geometry, and the yellow is my upper geometry. I have a couple things that I have to tell it. Where is the lower geometry? So You can see in that window there, it says, what is the height? In this case, it's right at 0, which would be table level. The overall height is the distance between the two shapes. For this example, it's 2 inches. Now, I could move that part off of the table. If I'm on a fixture or something, if it's up 1 inch, well then my lower height would be 1 inch. It would not be 0, right? Because the table is always 0. And this software will compensate for that when it does its post-process. Once I do the program, this is the wireframe of the actual program that it creates. So you can see it's going to apply my angle, and you can see how the shape changes from a circle to a square gradually as you move up that angle, okay? So I do have an example of this one for a simulation. So let's take a look at that, just to give you an idea of what that looks like. So now we're going to come here and do the simulation. So you can see how the upper and lower head are going to move totally independent of one another. So I'm cutting a square on the top and I'm cutting a circle on the bottom. Come to my stop and it cuts the slug. Nice feature of this software, I can actually test this slug release. And so by clicking a button, it lets me know that that slug will come out of my parent part. The reason for that is because it is 4-axis, totally independent programming. I could write a program where I could lock that slug inside of my part and not be able to pull it out, just based on whatever shape I was cutting. So it is a very nice feature of OptiCam. And that's that simulation. Okay, so that's it for the presentation. I just want to give you a quick overview of what the software has to offer, how easy it is to change your processing, change your concepts of how you want to do things. Right now we're going to go over to Alan Weeks, and Alan's going to give us a demonstration of the OptiCam software. So Alan, take it away.
Thank you, Brian. Thank you for having us here today. We appreciate that, and we also appreciate everyone being in attendance today to watch this presentation. My name is Alan Weeks, and the name of our company is Camtech Opti Solutions, and we represent the OptiCam Classic Wire EDM programming software. I'm going to be demonstrating a function in our software that's referred to as Wire Expert. Many people will recognize this as automatic feature recognition or programming directly from a solid. Over the years, we've seen more and more companies only wanting to provide solid models for programming. So the need has never been greater to have the ability to quickly and efficiently program directly from a solid model. So that's what I'm going to show you today. So I hope you find this information useful. So this is just a typical die block that I have on my screen. This is a very common situation that you see, is that the file was saved in the incorrect orientation, and when we import it in, you kind of see what we see now. If I look at this in the top view, you can see that this is definitely not in the correct orientation. We want to have this view with our land at the top. So if I fit that back to the screen now, what I'm going to do to remedy that is I'm just going to right mouse click on this bottom face and select the face option, and select this option, rotate to plane, just to get it in the correct orientation, which in this case we want that face to be in the XY plane. We want to datum that plane and rotate all the solid items. Now if we look at this and we go to our XY view, you can now see it is in the correct orientation. So once we've done that, we can go ahead and start our programming process. So to first of all get what features that we want to machine in this block or create a program for, I go to our Wire Expert menu, and I just want to select this option called Automatic Feature Recognition. So in this first process, I'm just going to create features for all the internal die features only. This is just a clearance cutout, so I'm going to come back and do this as a manual feature. But to get all my internal features, I'm just going to select internal die features only, select OK, and then it will highlight all the features that it found. Okay, so if I look at this first group, you can see that it's found this hole. It's put it in a magenta type color that you can see, and then anything that's been grouped with it will be in yellow. So these are actually been grouped together, Now if I look at what else it found, I found these bolt holes. I really don't want to include those, so I'm just going to right mouse click on those and say delete group, because those are already going to be pre-drilled. And then also these lifter holes, I don't want to do anything with them. They've been pre-drilled as well, so I'm just going to delete that group. Then we have the heel and the land for the die opening has been found. That's good. Then this hexagon has been found. We want to wire that as well. And then the taper, okay, has also been found. Now, one of the things I wanted to point out on this is that you see we have arc to arc conditions here. This can sometimes cause undercuts when you have arc to arc conditions. So I know that's probably going to cause an undercut or an issue with the toolpath or the NC code, I'm going to force this in just a moment to output this as a 4-axis code instead of just a simple taper, a varying taper. Okay, so all that looks good. So I'm ready to go ahead now and create a manual feature for this clearance cutout. So I just go back to the top of the Wire Expert menu, select manual feature. I'm going to do manual face selection, and I'm just going to pick these 3 faces. And then I'm going to end the selection, finish feature, and then end the command. So now it has a feature created as well. Okay, so all my features have been created. Everything looks good there. So I'm going to go back to my XY view, and I'm going to create all my machinings. And it's also going to create figures or project everything at the correct heights based upon the solid model. So I'm going to select this option called Make Figures and Machining from the features. Not going to apply any technology. I'm going to do that later. I'm going to go ahead and create a billet or workpiece from the solid body. And this is the option I was talking about. I'm going to process all the tapered features as 4-axis. I'm going to select OK, and then it should go ahead and apply toolpath to all those openings. So we'll give it just a minute to do that. And that's exactly what it looks like it has done. So let's go ahead and finish the programming side of this. So I'm just going to start at the top of my machining list. So I'll go to my machining tab at the bottom. These are all the machinings that's been created from those features from automatic feature recognition. So I'm going to go to my operations sequence. I'm going to give it a part number, part description. I'm just going to call it a die block. All of this is optional. You don't have to do this. So you can put this in or not. Okay, it created a billet that you see here from the solid body. I'm going to give it an NC file name. Just call it anything there. This is where I'm going to post the file to this directory. I can post it directly to the machine if it's networked or whatever user specified directory that I want. Where am I going to start my program? In this case, I'm just going to say I'm going to pick from the corner of this block. And then the reference position, I'm going to pick up the same location there. And I can pick my datums, G92, G54, G500, G54. In this case, I'm just going to use a G92. If I go to my technology, this is the material I'm going to be cutting, is steel. What wire type am I going to be using? Just brass 10 thousandths wire. Also, being that there's a lot of material being removed here, I am going to tell it to do all first cuts, all my rough cuts before I do any trim cuts. Okay, now that that's been done, I am going to come in here to my cylinders or my dowel holes. I'm going to go ahead and just pick these in the order that I want to machine them in this particular case because of where I'm starting at this corner. So I want this to be my first shape that I'm going to cut. So I'm going to do that. Now I'm going to select my technology based on 1.25 inch thick. So it brings up my select technology. In this particular case, I'm using the Makino U series. So I'm just going to do a 2-pass technology on pretty much everything. So 2 cuts there. This is the power settings, the offsets. So I load my technology, go to setup, 2 cuts. I'm going to put in a little bit of a clearance here. So I'm going to go minus 0.001 or a tenth per side, just to make sure that's a tap fit for those dowel holes. The tagging is the glue stop or the tab. We refer to it as tagging. So I'm going to put a 50 thousandths glue stop or tab there, and I'm just going to let it lead back to the center of the hole. And I'm going to stop and wire cut tags on the first cut. I'm going to lead on with the line, off with the line, and then we're going to cut counterclockwise with the wire offset to the left. And it's doing this because I'm using auto direction, which is mostly what you'll use most of the time. So I'll select OK to that and OK to this. This is where I could put comments in the code if I wanted to. In this case, I don't. So I'll just select OK to that. Now I'll do the heel and the land area for this opening. So I'll just go into here. Again, I'll just select my technology. We'll just do 2 cuts. So I'll select my nozzles as precision both away. Loaded up 2 cuts. We'll load technology. We'll go into setup. Pretty much do the same thing we did before. No clearance. We'll put in a tag distance again of about 50 thousandths. We will lead off about 30 thousandths. Drop the slug on the first cut. Lead on and off with the line. And then, of course, we're still using auto direction. So we'll say OK to that and OK to that. No comments in the code. So now we've applied technology for that. Now this hexagon here, we want to do something special to it. So I'm going to go into the standard profile operation for that, or the machining operation. We'll load 2 cuts again for this particular one. I'll use the same nozzle characteristics. We'll load 2 cut technology. Now in this particular case, instead of dropping a slug, I'm going to do a no core or pocketing operation, and I'm going to put in something like 0.125 as my start hole. But just to make sure that my hole location is good, the hole's not angled, I'm going to drop that down from the actual hole size, just so it starts no coring early and we don't have to worry about any short circuit or anything like that. So I'm going to no core pocket the first cut, standard pocketing, and I'm going to put an offset step in distance of 6.5 thousandths, just a little bit more than half the diameter of the wire. Then my trim cut will be my second pass, and then all these other items will apply. Lead off, I'll just let it lead back to the start hole location, and then you'll see the tagging is grayed out because we're not dropping a slug, and all these options we can just say OK to, no comments to the code. And we'll just take a quick look at what the no core tool path looks like. So not dropping the slug, but just slowly eating that material away. So we did our no core. Then our ruled surface operation, remember we had that option set to output the taper as a ruled surface. So it's taking all this information from the model. Really, this is just clearance, a clearance angle. So in this case, I'm going to just do a rough cut only. So just a rough cut only. If I go into setup, you can see it has a rough pass offset only. Tag distance, we'll put in something, again, about like 50 thousandths. Well, in this case, really, we don't need a slug. Not going to have a slug to drop because it's such a slight angle. So I'll just say no tag removal for that, and then we'll just let it lead off back to the start hole location. All this is preset for us, so we'll just say OK to that, and then OK to that. No comment in the code. And then lastly, what we'll do is we'll load just a one-pass technology for this. Okay, so I'll just go to my select technology, use the same nozzle characteristic, and then we'll just select a rough and cut only, load technology, and we'll go into tagging. We'll give it something like a 50 thousandths tag, and we'll just let it lead off. Let's see, about 50 thousandths as well. Drop the slug on the first cut. All of this has been preset. Select OK to that. Okay, so once we've applied all the machining, done everything that we wanted to do, associated the technology, then we can run our simulation. So if I go to simulation, I'll start standard simulation. Okay, so we'll just center this, fit it to the screen. I have my speed control. It'll stop at my optional stops. So we'll just go ahead and select that. We'll zoom up. You can see it stopped at the glue stop or the tag. It's going to drop the slug. And remember, we're roughing everything out first, so it's doing all our rough cuts first, removing the slug, and it's going to come and cut our rough cut of the heel, straight heel area, and also the land area. We'll just speed this up just a little bit. Just going to drop the slug, and it'll do the no core. We'll definitely speed it up for that. So it's just slowly eating that material out instead of dropping a slug. Then it should, when it finishes doing the no core, it should go and cut our taper cut, the clearance for the land. And then lastly, then it'll come and drop the slug for the clearance. Then it comes back and does all the trim cuts for the land. And I can reorder any of these that I want in the list. So the simulation looks good. That seems to be done. We can go back to our top view or XY view. If all the simulation looks good, we can zoom in and see graphically as well the number of cuts that it did as well. Then we just post-process our code, and then quickly and easily we were able to generate a program with different operations being done to it and have code ready to load into the Makino wire machine. So that's the steps of what you would do for using the feature recognition or the Wire Expert within the OptiCam Classic. So I hope everybody found this information useful. And Brian, I will turn it back over to you.
All right, thank you very much, Alan. Now, Alan and I are both available for questions, comments, anything that you've seen today, and we're ready to take your questions now.